first thing we got is an equation for y equals x squared minus 2x minus 3.
Y equal x squared minus 2x minus 3. Okay. Yep.
And we have to find the y-intercept, x-intercept. Yeah, we'll start with that.
Okay. What's the easiest one to find?
Y.
Okay. What's the y-intercept?
Because all you do is just plug in 0 for x, right?
Correct.
Oh, yeah.
I have an alarm here that I haven't figured out how to do anything but put it into snooze mode, which means it goes off every 20 minutes or whatever. Okay, so what is it? You shouldn't have to do any math at all. The y-intercept is always a constant.
Should just be -3.
Correct.
Doggy, get out here. I'll be right back. I'm going to go put my dogs outside.
What's that?
I'm going to go put my dogs outside. They're like licking on me while I'm trying to do homework.
Okay.
Let's go. After the game, let him in, please. Okay, I'm back. Sorry, it just.
So we found the y-intercept. Now how do we find the x-intercept?
I believe for the x-intercept, you.
What'd you do?
I'm trying to remember.
What'd you do to get the y-intercept?
You make it all equal to 0, right?
Make x equal to 0.
Yeah.
So what would you do to get the x-intercept?
You'd make the whole equation equal to 0?
You'd make y equal to 0.
Y.
Correct. Yeah, and that is the whole equation as long as y is all by itself on one side. So now when we solve this, we'll figure out what the y-intercept or the x-intercepts are. How do you solve that?
Okay. So
that's why this is the
Can we factor it?
Yeah, this is the harder one to get because you have to factor. You have to do some math.
Okay.
Factor.
So we get x in both at the beginning. And we should get 3 and 1. But is it positive 3 and negative 1?
Second step is always to figure out both signs. Don't forget that step. Don't do steps 2 and 3 all at once. Figure out both signs.
Okay.
What are they?
The signs would be 3 and 1, correct? Because
those are the numbers.
The signs.
We're talking plus or minus and plus or minus.
That would be plus. It'd be plus and minus, right?
Correct. In other words, the signs are the opposite. They have to be. It's the only way you can produce a -3. Now you're looking for the numbers. And what are they again?
3 and 1.
And the 3
positive 3, negative 1.
No.
The positive.
The larger factor, 3 is bigger than 1, goes with the sign of the middle term. So the 3 has to go with the negative sign.
Alrighty.
Which leaves
so the larger term goes with the middle sign?
Yes. Whenever subtraction is taking place.
Alright.
In other words, we were looking for factors of 3 that subtracted to the number 2. And once we found those two factors, that's when we're going to put the larger of those two factors with the sign of the middle term. Now, we haven't solved it yet. We've just factored it. So tell me what my solutions are. Where are the x-intercepts?
So we have x minus 3 equals 0.
Okay.
And x minus 1, or x plus 1 equals 0. So we have -3, 0, and 1, 0, parentheses, right?
No?
No? Okay.
Start with what you said. X minus 3 equals 0. Solve that.
X minus 3 equals 0. Well, you add the 3.
So there's
and then you just get x equals 3. Okay.
Now the other one, excuse me, you had x plus 1 equals 0. Solve that one.
X equals -1.
There's your two solutions. Hold on,
Let me turn that off real quick.
What's that?
I can tell you how to turn that off real quick where it'll stop bugging you.
Do, yeah, it's a Samsung and that's my alarm.
Okay, so do you know where to find like where you set like the clock app?
Yep, that's what I'm looking at is the clock.
Okay, so do you see the alarm that keeps going off?
Well, not anymore. Oh, up at the top?
Yeah, just hold it and you should get options to delete it.
Yeah, hold on a second. You don't. And I appreciate the, oh, now let's see, that was the one that went off at 5:01, yeah. Or 14:56. Let me turn both of those off rather than delete them. Okay.
Yeah.
Okay, thank you.
Mm-hmm.
I can't figure out why when I push off it goes into snooze mode instead of turning it off. But anyway.
I've had a problem with that too.
Yeah, I just switched phones. My old phone had the same alarm app and it worked perfect. I never had that problem. So anyway, what we have now figured out are the two x-intercepts. And
okay.
we would expect there to be two because we're looking at a quadratic that opens up and it's a parabola. So it usually goes through the x-axis twice. So when you solve most quadratics, you're going to get two solutions. Almost always.
Mm-hmm.
Always, but almost always. Now, next question is going to be what the domain is.
Yeah, I think so.
Okay. What is the what is
I have
the next question?
And I'll give you a picture of it through your email.
Okay.
It'll probably make life a little bit easier. Just a second. Okay. I'm sending this right now.
Okay.
Oops. That's contacts, not the gallery. Sure. Okay. Email. Sometimes it's fun. Okay.
Send it to my Gmail email.
Okay.
Because the other one gets forwarded to me and it takes a little bit longer to get to me.
Alrighty.
Is it sent?
Just a second, sorry.
Okay. Tell me when it says sent, and usually then I can look about 10 seconds later and I have it.
Okay. What's the, I also want to make sure the email I got is right. What, can you say it again? Oh, David, okay, I got it.
David Cowan, 1949.
Okay.
At gmail.com. And it's David Cowan spelled DavidCowan. And then 1949 at Gmail. Should come up as a default.
Yeah, for some reason it went off my phone, so I'm just looking.
Okay.
Can probably send this through the thing, it'd be easier.
Not sure I really need a picture of it. I can't imagine why I would need a picture. What are the other questions they're asking about this, besides the x and y intercept?
It says AOS.
Axis of Symmetry. Okay.
Axis of symmetry
Okay. Let's talk.
equals yeah, alrighty. Let's do that.
Well, the axis of symmetry always runs halfway between those two x-intercepts.
Okay.
Like that. Okay, my
Alrighty.
x-intercepts, even though I haven't graphed it like that, I just need numbers on them. What's halfway between -1 and 3?
-1 and 3.
Uh-huh. Figure out what
1.
halfway is. You add the two numbers and divide by 2.
Okay, so we'd get 2. So it'd just be 1.
1. So the equation of the axis of symmetry is x equals 1. It goes through the point 1, vertical line.
Okay.
Okay? What else
So,
do you want?
but the axis of symmetry here, it has like another equation attached to it.
Well, there's only one
Oh
axis.
wait, no, never mind.
There's
Sorry, there just wasn't a comma there. It was confusing.
Oh. And it is
this
the
says-
equation of a line. It is not a point. It would not be correct
Okay.
to say the axis of symmetry is where x equals 1. It's the line x equals 1. That is the equation of a line.
Okay.
Okay, what else? And
So,
the
yeah,
axis of symmetry is always halfway between the two x-intercepts. So the moment you have your two x-intercepts, add them together, divide by 2, and that's where your axis of symmetry is.
Okay. The next one I have is x equals -2b over 2a, and the vertex, yeah.
X equals what?
-b over 2a.
Oh, that's the formula for finding the x-coordinate of the vertex if
Okay.
it is in standard form. In other words, if we go back and we look at that first one that you gave me, and we look at the standard form, that's this one, x squared minus 2x minus 3. So if I only had this and I just wanted to find the vertex as quickly as possible, the best way to do it is to use minus b over 2a. Well, what would minus b over 2a be for this function?
Is -2b? Or is it -2x?
First of all, what's b?
Okay. Like, where does it fall in the equation?
No, tell me what b is.
-2.
Okay, so what's negative b?
+2.
Okay. What's a?
X squared.
No, a is the coefficient of the x squared.
A is the coefficient of the x squared.
So it's 1.
Oh, okay.
Okay. A,
That makes
B,
sense.
and C are never these variables. They're always the coefficient of these variables. Okay. So 2a would be 2. So that's telling us that the x-coordinate occurs at 1. And we knew that after figuring out the line of symmetry, because the line of symmetry goes right through the x-coordinate of the vertex. In other words, the x-coordinate of that vertex, that is a point, x equal 1, comma, whatever. We haven't figured out what the y-coordinate is yet.
Okay. Just to be sure,
Uh-huh.
the x, or the x squared, is 1, right? Because it's like the x supposed to represent 1 and 1. Is that right? Or is that just like the
coefficient? It's not the exponent. It's the coefficient.
Okay.
That's what a is. And
Alrighty.
implied 1 there. Because there's nothing written, it's 1. Okay?
Okay, that
In this
makes
case,
sense.
that's B, and that is C.
Alrighty.
Okay?
I got that now.
Okay. Now, at some point, they're going to want to know the vertex. They haven't asked it yet, but correct?
It's asking for the vertex right here.
Okay. What we just solved for, minus b over 2a, that is the x-coordinate only of the vertex. We don't know what the y-coordinate is. Yes, all we know is that the x-coordinate of that vertex is 1. The y-coordinate is going to be whatever you get when you substitute 1 for x. Well, what do you get? You get 2 times minus 2. That's minus 4. In other words, I can substitute it into this up here, but since I've already factored it, it's a little easier to substitute 1 in for x where it's factored. And then I get 2 times minus 2. So that the y-coordinate is minus 4. So the vertex is at 1 comma minus 4.
The vertex is as 1 comma minus 4.
Uh-huh.
Okay, hold on.
We got the 1 from the minus b over 2a. And we got minus 4 by plugging in whatever our x value was, which was 1, into the equation and figuring out what you get. Remember, this equation starts out y equals.
The vertex
equal to 0. We only set it equal to 0 when we're trying to solve for the x-intercepts.
Okay.
But the equation itself is y equals x squared minus 2x minus 3. So if you want to know what y is when x equals 1, just plug 1 in for x and do the math. And when you do that, you get minus 4.
Okay. Do you think we could make a new sheet and do like the vertex again?
Absolutely.
Just the same equation, just over. I think I'm getting it, but I just want to make sure because.
Should we do a different equation?
If we could just stick with the same one for now, and then maybe do a different one after that.
Okay.
So, yeah.
Start with y equals x squared minus 2x minus 3.
Okay.
So the first thing you want to do with all of these is to find a, b, and c.
So you said a is a coefficient which is in front of the x squared, right?
In front of the x squared, so a is 1.
Okay.
B is the coefficient in front of the x.
So negative 2. And then negative 3 is c.
Okay. Now, the vertex x coordinate, that's the way I write that. That doesn't say vertex, that says VERT of the x coordinate. Because the vertex is an x and a y. And b over 2a only gives you the x coordinate.
All right.
So when we substituted all of that in, we got that. So that's the x coordinate.
Okay.
Now, to get the y coordinate, vertex of the y coordinate, I substitute that into for x in the function.
Okay, so you substitute the result of the x coordinate in for x?
Exactly.
Okay.
And that's the way you always do it. There is a complicated formula for the y coordinate, but nobody teaches it because that's not the easiest way to do it. The easiest way to do it is once you have the x coordinate, plug it in and figure out what y is at that value.
Okay.
So in other words, it would be 1 squared minus 2 times 1 minus 3, which is minus 4.
All right, that makes sense. Okay. Yeah, I think I got it.
What else you got?
We have to graph that equation, the y.
Okay.
The one we just did.
Yeah, let's go back to some of the stuff we figured out, because that'll help graph it.
Okay.
We know a few key numbers, right? We know the y-intercept, we know both x-intercepts, and we know the vertex.
All right.
Okay, so let's start there. I'm going to start over here on the left. Now, let me use black. So first I go to my vertex, right there. 1
Okay.
comma minus 4. Next, I go to where, what are the x-intercepts?
We have 3 and -1.
Okay, so there's 3. There's -1. So I know that I have a parabola. 3 points define a parabola. That's all you need. Now, if
Okay.
your teacher wants 5 points, it's easy
No, he
enough to
doesn't.
get the 5th point. I'm sorry, what?
Oh, he doesn't.
Okay,
I know
so
that for a
just
fact.
graph it. And you
Yeah.
really only need 3 points. You do need 3. In other words, you can't just graph the vertex
Yeah.
and draw a parabola. But we do know another point here because we figured out the y-intercept. So that y-intercept right there comes at -3. And that would actually
Okay.
allow me to figure out that point. So if they wanted 5 points, it'd be real easy to find that 5th point.
All right.
All right.
Before we go to the next one, where did the 1 minus 4 come from? Like the
That
coordinates?
was the vertex. In other words, we
Okay.
figured out the x-coordinate
Oh, alrighty.
minus
That makes
b
sense.
over 2a, and then we plugged it into the equation to get the y-coordinate.
So
And that's where we
with
got
the
1
vertex,
minus 4. We got the x-intercepts by factoring it. We got them from there, which turned into these two x-intercepts. And there's our
okay.
3 points. Once you got the vertex and both x-intercepts, that's all you need to graph it.
So is the vertex the point you build off from?
Vertex is the most important point on any parabola. You can see why. It's the only point that
Yeah, it's like the focal point, right?
well, it's a minimum point. If the parabola were turned upside down, it would be a maximum point. And that's why it becomes the most important point, because it's either a minimum or a maximum. And that frequently is what you're looking for in a function. If you give me a function, one of my most common questions is going to be, well, where does the maximum or the minimum of this function occur? And it's always at the vertex, if it's a quadratic. If it's something higher, like a cubic, not the same thing. But quadratics either have a minimum or a maximum, depending on whether they open up or down. And those occur at the vertex. So the vertex is easily the most important point on a parabola. That's why they have you memorize this minus b over 2a. That doesn't give you the vertex, but it gets you started. The other way would be to take that equation and put it into vertex format.
Okay.
And that is going to give you y equals x minus the x coordinates squared plus the y coordinate. In other words, when it's in vertex format, then you're looking at the vertex. You don't have to do any math at all. You know the vertex has to be at +1, -4. Now there is an
Okay.
a in front of that, but it turns out that it's a 1. That's why I didn't write it. In other words, there are 3 standard formats, and each one of them has its advantages and disadvantages. This is standard format right there, where everything's on one side of the equation, zeros on the other. This is x-intercept format, where you're basically staring at the x-intercepts, opposite that, opposite that. That has its advantages sometimes. The most valuable one is vertex format, which is that one right there with an A.
Alrighty.
And the reason it is because it immediately tells you where the vertex is.
All right.
Okay, what else you got? Anything left on this problem, or should I find a new page here?
No, that problem's good.
Okay.
So the next problem we have is y equals 4x plus 4x. Or no, it's y equals 4x squared plus 4x minus 3. And I don't know how to verbalize this, I forgot, but it's this is like C plus square. I know it's like stands for something. Hoping you know. Is it like, I think it's like the squared of something, I don't remember what it's called.
B squared minus 4AC?
That's not the equation it has here. I think it's the I just don't remember how to verbalize it. I completely forgot it. Like the name of the equation.
Quadratic formula.
Okay.
Minus B plus or minus the square root of B squared minus 4AC. These are the same A, B, and C that we were talking about, all over 2A. Now, why do you need this? Because most of the time you can't factor these. If I try to factor that, it's not going to factor. If you,
okay.
Well, I don't know. There's always a question as to how much time you spend trying to factor it until you give up, and then you have to use the quadratic. Well, that doesn't work. Oh, yes, it does. No, it doesn't, but that does. That produces a plus 4x in the middle. So there's no need to use the quadratic formula. The quadratic formula is always the harder way to go. But if we set that equal to 0, we can figure out our x-intercepts.
Okay.
What's the question on this that they want?
It's like the same one we have to find the vertex, graph it, and also it's an equation that says C plus square. I don't remember what that stands for.
Do not know what that means. Have no idea.
Yeah, I need to ask him what that means because I forgot.
Okay. So
it's like his personal shorthand, so I need to like.
Okay.
That's why.
This quadratic formula over here, that is something you need to memorize.
Yeah.
The sooner the better. But
I think we've been over that kind of.
We don't need it for this problem. We would make that 3 a 5, and we wouldn't be able to factor it. And then we would have to use the quadratic formula. But in this case, this factoring works. That produces that quadratic if I multiply it back together again. So the question is where's the y-intercept?
The y-intercept, that's just plug 0 in for all the x's, right?
Mm-hmm.
So it's just -3.
Okay. X-intercept?
And that makes the whole equation equal to 0. And we can factor it.
Well, we've done that. So where's the x-intercept?
So we have 0 equals 2x plus 3.
Okay.
And 0 equals 2x minus 1. And with the first one, we subtract 3, which makes it 2x equals -3. And you divide by 2, and you get -3 over 2.
Okay. Second one?
And then you have 1 over 2.
Okay. Now, that's actually pretty valuable, knowing the x-intercepts. And here's why. Because we don't have to go through this vertex stuff anymore. In other words, if I know the x-intercepts are between -3/2 and 1/2, well, now I know where the axis of symmetry is. Now, first of all, I know this thing opens up. Okay, so the vertex has to be somewhere down there. But without a doubt, it lies halfway between those 2 points. So what is the x-coordinate of the vertex? It's easier to figure it out this way than it is to use -b over 2a.
So is it -2 or -1? I mean.
Add these 2 numbers together and divide by 2.
So we have -2 over 2 divided by 2, which is -1 over 2.
-1.
That's -1.
-1/2.
Yeah.
Notice that that is exactly 1 unit away from the vertex or the x-intercept on the left, and it's 1 unit away from the x-intercept on the right. Okay?
Okay.
So here, let me make it a little bit more in the center. So we know that our vertex is down here, and I know the x-coordinate of the vertex. It's -1/2. So I just got the same thing that I would have gotten by using minus b over 2a. I just got it a little quicker. It's easier to add two numbers and divide by 2 than it is to substitute into minus b over 2a. You with me?
Yeah, I think I got you.
Okay, now we need the rest of the vertex. I need the y-coordinate of the vertex.
Okay, that's just 1/2 plugged into the x's, right?
Okay, let's do that.
Of the original problem.
Yeah. Now, sometimes it can be a little easier to plug it into the factored form. And you can see why. My x-coordinate is -1/2. The math is going to be much easier if I do it this way.
So we just have 3 minus 1, pretty much.
Well, hold on. I fill in everything and then I do the math. I don't try to do it all in one step. So this is -1 plus 3, so that becomes +2 times -1 minus 1, which is -2. Again, the y-coordinate is -4. All right. What I got was -4 when I plugged in -1/2. And the math was easier to plug it into that than it would have been to plug it into that. Because that one I would have had to square -1/2. I would have had to put in a fraction into there. And this one, it worked out nice and easily because each x was being multiplied by 2. So it immediately turns into an integer. Okay? So now I know how to graph it.
Yeah, okay.
There's only one way to graph it. It's got to go through the vertex, it's got to be a parabola, and it's got to go through both x-intercepts. And if I want my line of symmetry, which is usually use a dotted line, because you don't usually see the line of symmetry. It's just they want you to calculate it, because the key to the line of symmetry is this parabola is symmetrical about it. In other words, that distance right there is the same as that distance right there. The parabola is perfectly symmetrical about the line of symmetry. Not the y-axis, but the line of symmetry. Okay, what else did they want?
No, that's it.
Okay.
Yeah.
So the biggest problem here is the factoring.
Okay.
By problem, I mean the biggest difficulty. So once you know how to factor, then you're always going to be able to answer all these other questions. They become pretty basic algebra.
Okay. So the next one I have is number 3, where all it says is solve.
Okay.
And it's 7x squared minus x equals 0.
What's the first thing I look for in factoring?
3 variables, right? Or no, is that not important?
3 techniques for factoring. And you always want to look at them in priority. The very first one you want to look for is greatest common factor.
Okay.
Can you do that here? In other words, this is not a standard quadratic, notice. There is no C term.
All right.
Okay, when you don't have a C term, that means you're always going to be able to factor out at least an x.
Okay.
So that's the greatest common factor, x.
It's x?
Yeah. What's left?
Okay. 7 and another x.
What's the rest of it?
-1.
Mm-hmm. Now, how do I solve that? I got two things multiplied together equals 0.
Do you distribute? No, if you
Well,
distribute, it's
we
gonna be a
just said
normal one.
distributed. In other words, if
Yeah,
you distributed, you'd be back to the square one.
yeah. Would
No,
we
there's a
subtract?
principle. There's a principle in algebra that says if you have things multiplied together that equal 0, then they're equal to 0. Set each one equal to 0. That's what we did before, right?
Uh-huh.
When we had x minus 1 times x plus 3, you set the x minus 1 equal to 0, and you set the x plus 3 equal to 0, and you solved. Well, same thing here.
Okay.
So what's
So
the solution?
so are we setting the x's to 0 then? Which we get.
This is one thing. This is the
Okay.
other that it is being multiplied by. If
Okay.
I'm multiplying x times this, one of them has to be 0 by definition. So the way
Yeah.
I solve it is I let both of them be 0, and that gives me two answers, just like you did it before. So the first answer is x equals 0. The second answer is 7x minus 1 equals 0, which makes x equal to 1/7. So there's your
Okay, that
two
makes
answers.
sense.
And you almost always have two answers, and for some reason everybody wants to ignore the x. If I gave this question to half my students, they would say 1/7 only.
Okay.
But the fact is that x can certainly be 0 also to make this equation true.
All right, I think I get that now.
All right. And if it's three things multiplied together, you do the same thing. One of those three things has to be 0. And when I say things, I don't mean x, I mean the thing. This is the thing that has to be 0. Or this thing.
Okay, I get that now.
Okay.
The next problem we have is 49x squared minus 16 equals 0. Yeah.
First step.
So on this, is this one different? Would we just? No, it's
It
not.
is different. Notice,
Would
first of all, that there's no greatest common factor,
we? Mm-hmm. Could
but
we just
it is
add
missing
16?
an x term. And
Mm-hmm.
they're missing an x term. There's two ways to solve it. One is
Could.
taking the square root of both sides. The other
Okay.
is dopes. In other words, you got greatest common factor. That's what you always look for first. And then what I look for second is probably dopes, difference of perfect squares. And then there's a third technique where you're going to take the square root of both sides. And then the fourth technique would be the standard quadratic factoring that we've been doing. But you always want to do these three first in priority because they're easier. In other words, greatest common factor is pretty easy, so is dopes. And square root. Now this problem can be done by either of those two techniques.
What's the dope stand for again?
Difference of perfect square.
Difference of perfect squared.
Notice why that works on this. That is a perfect square. That is 7x squared. And
So how would you do that
that
then?
is a perfect square. That is 4 squared. So
Yeah.
I have, and they're being subtracted, so I have the difference of perfect squares. Each one of them is a perfect square, and I'm taking the difference of them. And that always factors a squared minus b squared is the difference of perfect squares. It always factors into a minus b times a plus b. So if we use difference of perfect squares on this problem, what does it become when you factor it?
Okay. So would we have for a and b would wait, are you factoring out the 49 with the 16?
No? I'm
Okay.
looking at 49x squared and realizing that that's a perfect square. So I need to figure out
So
what a is. A is
it's
the square root of
7 then?
7x, right?
Yes.
That's a.
So 7x.
What's b?
7x.
B is the square root of this number.
4.
Uh-huh. And then once you get that first factor, you're done thinking. This next one is just the conjugate, always.
Okay.
Okay? Now, if we solve this, we get x equals either 4/7 or minus 4/7. So plus and minus 4/7 are our two answers by setting each of
Okay.
these equal to 0 and solving it. You with me?
All right. Yeah, I got that now.
Now I want to show you how to do exactly the same problem, only using square root of both sides, which a lot of people would find easier, but it's easier to make a mistake. If I do square root of both sides, then first step is I move the 16 on the other side. Second step is I divide both sides by 49. Third step
Okay.
is I take the square root of both sides. But whenever I solve an equation by taking the square root of both sides, I got to put a plus and minus always in the beginning of my answer. Now the square root of the numerator is 4, square root of the denominator is 7. So I got the answer pretty quickly that way.
Yeah.
Although not everybody would know what the square root of 16 over 49 is. But the problem with doing it by taking the square root of both sides, most people leave this off. They forget it. By most, I mean 90%. So they come up with one answer only, and you lose half credit on the problem. If you solve this by using dopes, you can't get it wrong. You end up with two factors. So x is either equal to plus 4/7 or minus 4/7. In other words, the plus and minus takes care of itself. Whereas when you take square root of both sides, you got to always remember to start the answer with the words plus or minus. If you forget, you're going to lose half credit by doing it that way.
Okay.
The advantage of square root of both sides is you don't need it to be difference of perfect squares. If I turn that 16 to a 15, well, I can still do the problem by doing different or square root of both sides. I can no longer do the problem by difference of perfect squares because 15 is not a perfect square number. But I could certainly move the 15 to the other side, and then I would have x squared equals 15 over 49, and x would be equal to plus or minus the square root of 15 over 7.
Alrighty.
I would get the answer using the square root of both sides method, even if it wasn't perfect squares. So it's probably a little bit, I would say in real life, it's the more common method. You're going to run across more problems that you would use this to solve as opposed to dopes. But on tests in algebra class, they're going to give you a lot of dopes. They like difference of perfect squares. They just want to make sure that students will recognize difference of perfect squares.
Alrighty. Okay. That's about all I have for right now.
Okay.
Oh, yeah. I'll call you. I'll have another session tomorrow and a couple more sessions probably tomorrow and Monday.
Okay.
And then we'll be good. All right. Thank you. I appreciate it.
You're welcome, Eric. Talk to you tomorrow.
All right.
Bye-bye.
Bye.